In this video, we're going to talk about performing compositions of transformations or sequences of transformations. This means doing multiple transformations, one and then the other. In the first question we have here, we have triangle PQR on the grid. And the question's asking which quadrant is going to contain point R prime, which is the image of point R. So that means after the transformation occurs. Image means after the transformation occurs. After a 90-degree clockwise rotation centered at 0, 0. So I'm going to dot our center of rotation for point R. It's specifically for this point R over here. And we're going 90 degrees clockwise. So if we think of the way the clock moves, the way that the numbers on the clock go, clockwise is in the direction that the numbers go in numerical order. So if we move 90 degrees, each quadrant on the grid is 90 degrees. So that will move us one quadrant. So it'll be located somewhere down here in this box. Well, that's after the 90-degree clockwise rotation. Then it says this is going to be followed by a reflection over the x-axis. So if we now reflect this point over the x-axis is right here. So it's going to go back up here to this box. This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So the point is going to be located somewhere in quadrant number 1. Over here, we have triangle ABC, and it shows us triangle A prime, B prime, C prime, and triangle A double prime, B double prime, C double prime, which are the images of the original triangle after a sequence of rigid motions. So we know that either a translation, reflection, or a rotation occurred. Those are rigid motions. Rigid transformations make congruent shapes. So any transformation could have occurred aside from a dilation. Nothing changed size here. So now we have to pick which sequence of rigid motions is the correct one. So let's go answer choice by answer choice until we find one that works. From looking at triangle ABC to triangle A prime, B prime, C prime, I see that triangle ABC flipped over. It reflected over the x-axis. So I'm going to knock out 1 and 2 because I know a reflection happened first. And now I see from triangle A prime, B prime, C prime to triangle A double prime, B double prime, C double prime, the triangle turned. And I know a turn, and let me just write this here, reflection. I know a turn is a rotation. So that brings me the answer choice number 4. And for all of the questions going forward, you should pause the video, take a moment to think about which answer choice that you would select, and then you can unpause the video to see if you picked the correct answer. Here we have triangle ABC and triangle DEF graphed, and it's asking us which sequence of transformations maps triangle ABC onto triangle DEF. So triangle ABC is the pre-image, so that means before the transformation, and triangle DEF is the image, that means after the transformations occurred. So let's take a look answer choice by answer choice. Number 1 says a reflection over the x-axis followed by a reflection over the y-axis. I'm going to actually try it out because for me, it's hard to visualize if this is going to make it look like it should. So 1, 2, 1, 2. I'm going to move each of the points in equal number of spaces, 3, 1, 2, 3, over the x-axis. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, and I'm not going to use a straight edge. I probably should use a straight edge, but I just want to get a general sense of where the letters are going to be. So that is after the reflection over the x-axis. We have A prime here, B prime over here, and C prime over here. And now let's see when we do a reflection over the y-axis if it lands in the right spot. This is one space from the y-axis. It's going to land right here. So that's going to be C double prime. And C and F should match up. So far, so good. 1, 2, 1, 2. So A double prime lands where D is. And A and D should match up, so that's good. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that is where B double prime lands. And B and E should match up. So answer choice 1 ended up working, and it's always nice when that happens. But the best way for you to know if a transformation is going to work or a sequence of transformations is going to work is to actually try out the transformations on the grid. So many people think from looking at it, oh, it looks like this could have occurred, right? And they pick the answer. But if you don't try it, you won't actually know if it is in fact going to work. Over here, we have congruent triangles ABC and DEF. And I know that rigid transformations make congruent figures. So I know that rigid transformations occurred here. Which sequence of transformations maps triangle ABC onto triangle DEF? So once again, I'm going to go answer choice by answer choice, and I'm going to hope it's pretty early on because I am going to try out all of these answer choices. Number 1. And ABC is our pre-image, so that's our starting triangle. The direction does matter. And triangle DEF is our image. So let's keep that in mind. So number 1 says a counterclockwise rotation of 90 degrees counterclockwise is this way. So I'm going to take ABC and I'm going to go in the counterclockwise direction. So that means it's going to land in this quadrant down here, which is quadrant number 3. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4, just so that it's there for reference. Followed by a translation 8 units to the right. So let's see. I'm going to actually take this figure and rotate it. Remember, when you rotate, you need to keep distances. So the distance from the center of rotation, which is the origin, to let's say point B, I'm going to do point B first, is 2 up and 2 over. So I know it's going to land in quadrant 3. So I'm going to do the same move. I'm going to go 2 and 2 because I need to preserve distances. So that's B prime right over here. I'm going to do the same thing. I'm going to count the spaces from the center to another point. I'll do A next. So that is 1, 2, 3, 4, 5, 6 up and 2 over. So I'm going to do the same thing. 1, 2, 3, 4, 5, 6. 1, 2. And I find where a double prime lands. And then finally, 2 up. 1, 2, 3, 4, 5 over. To get from the center, which is the origin, to point C. 2, 1, oops. 1, 2. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I counted that correctly. Nice. Okay. Let's make sure that the triangles are oriented correctly. So A should match up with D, and those are in the same spots. B should match up with E. Those are in the same spots. And C should match up with F. Those are in the same spots. So all that's left for us to do is to make sure that the translation of 8 units to the right is going to work. So I'll just take 1 point on triangle A prime, B prime, C prime, and the corresponding point, the point that matches up to it in the same spot on the other triangle. And I'll just count 1, 2, 3, 4, 5, 6, 7, 8. So the translation of 8 units is what's needed. So once again, we got lucky and answer choice 1 worked. But once again, if it doesn't work, you should move on to the next one and try it out. The only way to know if it's actually going to work is to actually try the transformation and do it on the actual grid. Otherwise, you won't know. Over here, we have triangle ABC is congruent to triangle DEF. And we're finding which sequence of transformations maps triangle ABC. So triangle ABC is the pre-image before the transformation onto triangle DEF. So triangle DEF is the image. So we're going from ABC to DEF. So once again, I'm going to do the same thing that we've been doing. I'm going to go answer choice by answer choice, and I'm going to stop when I find one that works. So a reflection over the x-axis followed by a translation. So I already kind of see that's not going to work, and I'll explain why. Because if I take triangle ABC and I reflect it over the x-axis, since it's a mirror image, it's going to be facing like that. And then a translation just slides, so it's not going to be oriented the same way as triangle DEF. So since the orientation's not going to be correct, that answer choice is not going to work. Now for answer choice number 2, a reflection over the y-axis followed by a translation. This one might work, but let me sketch it out. There's not actual grid here. There's not actual like coordinates on the grid other than the x and y axis. So I can't do it super accurately. So I'm going to just do it approximately. So when I flip this over, it's going to look something like this. That's going to be A prime. It's going to be B prime, and that's going to be C prime. Let's make sure the orientation's correct. A needs to match up with D, and those are in the same spots. B needs to match up with E, and those are in the same spots. So that means C and F also match up. Followed by a translation. It looks like now, since they're oriented the same way, if we just slide down, we will land on triangle DEF. So answer choice 2 here is the correct answer. Once again, sketch it out, and that's how you know if your answer is correct. Here we have triangle ABC and triangle RST on the grid. And we need to find which sequence of rigid motions will make them congruent to each other. So basically, it's just saying which sequence of rigid transformations makes one into the other. Because if we find a sequence of rigid transformations that can turn one into the other, that means it's congruent figures, because rigid transformations make congruent figures. So let's see. A reflection over the line y equals x. The line y equals x, I'm going to put it over here, has a slope of 1. Whenever you don't see a coefficient on the x, there's an invisible 1. And since you don't see a y-intercept, that means it was plus 0. You can also say minus 0, same thing. And that means the y-intercept is at 0, 0. The slope of 1 means to find each of the points, you just count up and over one box, rise over run. So up and over. And I'm going in the reverse way to get points on the other side of the graph. And I'll just go the whole way. And the straight edge would definitely be more accurate. But there we go. Okay, so let's check it out and let's see if that's going to work. So I'm going to have to count diagonally, which is going to be a bit annoying. And it doesn't look like it matches up to me. Point C does not align over here with point T. So to me, it's looking like it's not going to work. But there is a rule for reflecting over the line y equals x, because it could be hard for a lot of people to count diagonally over the line and move an equal number of spaces on the other side. A very easy rule for y equals x. You take your original point, and all you do is you switch the order. So for example, point C, which I know has to match up to point T, and I just selected point C first, has the coordinates -1, 2. So I know T should be 2, -1. Just switch the order of the coordinates. 2, -1. It's not. It's 1, 2, 3, -2. So that transformation is not going to work. So I'm going to reset over here so we could try out the next one. But I am going to leave up the rule for the reflection over the line y equals x. Okay, so now we have rotation of 180 degrees centered at 1, 0. So 1, 0 is this point right over here. So what I'm going to do is I'm actually going to do the rotation with 1 point, and I'll just do C again. I know it needs to match onto T because of the letters of the triangle, but also it's going to be the easiest one for me to rotate because it's the closest point on triangle ABC to the center of rotation, to that point 1, 0. So what I'm going to do is I'm going to keep in mind that when we rotate, we turn the figure, and we preserve distances. 180 degrees, doesn't matter the direction, it's going to move two basically boxes around. So I know it's going to land in this quadrant because quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So I know it's going to land in quadrant number 4 when I go 180 degrees. Now what I'm going to do is I'm just going to count from the center to point C. And that's 2 up and 2 over. So I'm just going to do the same thing in this box, starting at the center, 2 over, and 2 down. And I land right over here at point T prime, which is what I should land at. So this one is going to work. We don't have to try out the other ones, but you absolutely can if you want to. And that is the transformation that will land one onto the other. And it's funny because it's a sequence, but we only needed one here. A sequence, if a question asks for a sequence, it could sometimes be done with one. There's usually many ways that we can accomplish the same goal. So sometimes a sequence, they'll say a sequence, but there'll only be one, which is a little bit confusing. But a sequence could be one or it could be many. Okay, over here, we have triangle ABC and we have triangle QRS, which is the image of ABC. So ABC is the image of QRS. So QRS turned into ABC. So I'm going to circle that. QRS is the pre-image. Sometimes that wording can be a bit tricky, but we need to know what direction we're moving in. Oh, sorry, I totally misread that. It says triangle QRS, the image of triangle ABC. So this is the image, and triangle ABC is the pre-image. Almost just got that question backwards there. So triangle ABC is turning into triangle QRS. And we're describing a sequence of transformations that would map triangle ABC onto triangle QRS. And there are often multiple ways that you can accomplish the same goal. What I always like to do is I always like to try to get the orientation the same. So I want to get triangle ABC facing the same way as triangle QRS. And once I have that done, then life is going to be a lot easier for me. So what I'm going to do is first I'm going to rotate it. And once again, there's many ways that you can do this, but I'm just going to do it the way that I see at the moment. And I'm going to rotate around point A. So what that means is point A is going to stay where it's at, and point A is the point -2, -1. So my rotation is going to be around the point -2, -1. And the way I'm going to rotate is I'm going to rotate counterclockwise 90 degrees. So I'm going to put this over here, rotation, big R stands for rotation, around the point -2, -1. And then I'm going to put how many degrees? 90 degrees, and my direction in the counterclockwise direction. CCW usually stands for counterclockwise. So I'm going to rotate now. A is going to stay put because that is the point I'm rotating around. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3. Okay. And the orientation is still not the way that we want it. So I'm going to do a reflection so that A can match onto S. Wait, sorry. A needs to match onto Q. A needs to match onto Q. So I need, when it flips, A to match onto Q, I need C to match onto S, and I need B to match onto R. And I need them facing the same way. So I'm going to reflect. And I'm going to reflect over this line over here. And that is the line X equals -2. So I'm going to write that here. Then reflect over X equals -2. And when I reflect over X equals -2, since A and B are already on that line of reflection, they're going to stay put. So the only point that's going to move is C. 1, 2, 3. 1, 2, 3. Remember, reflections keep distances on either side of the line of reflection. And now everything is oriented properly. And now I can simply just translate. So I'm just going to take a point from this triangle. I'll just take B, and a point from this triangle that's supposed to match up with, I'll just take R. And I'm just going to count 1, 2, 3. So 3 up, 1, 2, 3, and 3 over. Then translate 3 units to the right and 3 units up. Once again, you might be thinking that you see another way to do it, and that's fine. There's often many different ways that you can describe an accurate sequence of transformations to take one shape onto another. But if you're thinking something else would have worked, then you do need to try it to make sure that it actually does. Because the only way that I know for sure that my suggestion worked is to actually try it out on the grid. And what I was thinking might have not worked, and then I would have to revise based on what happened when I actually did it on the grid. We have the same kind of question here. We're once again describing a sequence of transformations that will map triangle ABC onto triangle DEF. So the first thing I'm going to start with again is trying to get the orientation the same. So I'm going to do what I did before, and I'm going to try to make triangle ABC look like triangle DEF. So I see that if I flip it over, they'll be looking similar. I don't know about exactly the same, but they'll be looking similar. So I'm going to reflect over the x-axis. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Looking pretty good so far. Let's just make sure that things match up. So A is supposed to match up to D, and it does. B is supposed to match up to E, and it does. So that means C matches up to F. Amazing. So I'm going to put that here. Reflect over x-axis. And then since it's oriented correctly and they both look the same, we can simply just shift or translate. 1, 2, 3, 4, 5, 6. Then translate 6 units to the right. We don't need any transformation up and down, just 6 units to the right. Okay, this one over here is a little bit different because this time we are not talking about a sequence of transformations on the grid. This time we have off the grid, so it's going to be a little bit more tricky to fully describe how to get one triangle onto the other. So I'm trying to map triangle ABC onto triangle DEF. So first I'm going to use the same process as before where I want to get them looking the same way. And I see that if I turn triangle ABC, so if I rotate it, it's going to look the same as DEF. When I rotate, I need 3 things. I need a point I'm rotating around, I need an angle, and I need the direction. So I'm going to rotate around point C because it's a point I have without making a point up. And when the shape rotates around point C is going to stay put. So I want to rotate in the clockwise direction until this triangle looks the same as triangle DEF, like I drew. But I need a way to describe when to stop rotating because I don't have a grid here. So I can't say 90 degrees, right? This might be a 90-degree angle that I rotated at, but it might not be. It might be 89, it might be 91, it might be 93. I have no way of actually knowing what that angle was that I rotated at because I don't have a grid here to help me figure that out with grid lines and boxes that are for sure 90 degrees, so I don't know that for sure. So one way that I can describe when to stop rotating is I can say rotate around point C clockwise until DF is parallel to AC, because that indicates that's where I want to stop rotating, where those 2 lines are parallel to each other. So I'm going to write that here, rotate clockwise around point C until AC is parallel to DF. And then all I need is a translation because then my orientation's good. They're facing the same way. So usually when we're not on the grid, we pick a translation vector, which is just a line segment. So let's translate along CF. You could pick any. Then translate along CF. That could be our translation vector. And I'm just going to get very specific. They gave us information in the question about what needs to match up. So I'm just going to say until AB matches up to DE, because that's what they told us in the question. AC matches up to DF. And angle A matches up to angle D. But my answer would have been good if I just said then translate along translation vector CF. That would have been fine. I just got very specific with the information from the question, because if they give you information in the question, it helps make a stronger answer if you use the information from the question. Okay, over here, we are turning bike into golf. So you might think just a translation's needed, but don't be fooled. B needs to match up to G. B is on the left of this shape over here, whereas G is on the right of this shape here. So the orientation is not correct. So this is going to require a flip or a reflection. So I'm going to reflect over the y-axis. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. Okay, let's check the orientation. B is now matching up to G. I is now matching up to O. K is matching up to L. And E is matching up to F. So this looks good to go. So reflect over y-axis. And then we just need to see how much to translate by. F needs to match up to E. 1, 2, 3, 4, 5. Then translate 5 units up. Okay. Let's check this one out over here. We're going to describe a sequence of transformations to map dir into D prime, E prime, A prime, R prime. I'll just say dir prime. So here it looks like a flip is needed because A is on the right over here, but A prime is on the left over here. So I'm going to reflect over the y-axis. 1, 2, 3, 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. D stays in the same spot because it's already on the y-axis. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then the orientation's good, and all we need after that is a translation. So I'm going to just right here reflect over y-axis. And then to see what the translation is, I'll just take R and R prime. That's 2 to the right. 1, 2, 3, 4, 5, 6, 7. Then translation, 2 to the right and 7 down. I'm just using notation here. The first number in the notation stands for the movement on the x and right axis, the x-axis, so left and right. If it was to the left, I would have wrote -2. And the second number represents the movement on the y-axis. Since I went down 7, I put a -7 to indicate the down direction. Sometimes you might see some notation for a composition of transformations. When you see that circle, whatever you see on the right is the transformation that happens first, followed by the transformation that you see on the left. You kind of read it backwards. Let's take a look at one together where we see this notation. So it tells us that the vertices of triangle ABC are negative 6, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. Negative 4, 8, 1, 2, 3, 4, and then 8. And 1, 6, 1, 1, 2, 3, 4, 5, 6. And we need to first do a reflection over the y-axis. Remember, whatever's on the right of the circle happens first. So when I reflect over the y-axis, that point is one spot from the y-axis. So we're going to move it one space to the other side. So there's C prime. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oh, sorry, that's A prime. I'm mislabeling. Okay. And now we're going to do a translation of 4 to the right and 5 down. So I'm going to take each of the reflected points and slide it 4 to the right and 5 down. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. And that is my figure after both transformations. That is triangle A double prime, B double prime, C double prime. And it does say to state the coordinates, so I should write all the coordinates down, but to save some time in this video, because it's already been a while in this video, I'm not going to write each of the final coordinates down. But you definitely should do that if it's a state and label the coordinates. Let's try one more example. So R is negative 6, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. S is negative 7, negative 2. 1, 2, 3, 4, 5, 6, 7, 1, 2. And T is 1, 4. 1, 2, 3, 4. And the transformation that we're doing first is a reflection over the y equals x. So we spoke about this earlier in the video, that it's a slanted line diagonal with a y-intercept of 0 and a slope of 1, but it could get really hard to count diagonally when you're reflecting over a slanted line. So we have a really nice rule, which is that if you take the coordinate of the original point, you could just switch the order, and that's for a reflection over the line y equals x. So the coordinates of point R was negative 6, 5, so it's going to become 5, negative 6, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. The coordinate of T was negative 7, negative 2, so it's going to become negative 2, negative 7. And the coordinate of S was 1, 4, so it's going to become 4, 1. And then finally, we have a translation of negative 2, 3. So 2 to the left and 3 up. Remember, the first number is left and right. The second number is up and down. So I'm going to take each of my reflected points, and I'm going to slide 2 to the left and 3 up. Let me get a different color. 2 to the left, 1, 2, 3 up. 2 to the left, 1, 2, 3 up. 2 to the left, 1, 2, 3 up. And here I have my final triangle, my final image after the sequence of transformations, triangle R double prime, S double prime, T double prime, after both the reflection over the line y equals x, followed by the translation of 2 to the left and 3 up.